Hi everybody and welcome to Mr. DeGoris's Math. Why are you laughing? Hi everybody and welcome to Mr. DeGoris's Math YouTube channel. Today we're talking about reducing radicals. So a radical is an expression that has a square root sign in front of it. Sometimes that radical is going to have an index. If it doesn't have one, we're assuming it's a square. So this question is, reduce the square root of 288. Or rather, come up with a simpler radical for it. Much like reducing fractions, where we're looking for a number that divides into the numerator and denominator, we're going to be looking for a square number that divides into the argument. That's that number underneath the radical. That's our argument there. So I have to think to myself, what's a number that multiplies to 288? And better yet, what's a perfect square that multiplies to 288? Well, I'm looking at this and I'm going 4. 4 just seems to make sense. I believe it's a 4. I'm thinking there's a 4. I feel like 4 goes into 288. And I know that it does. It goes in 72 times. So this is 4 times 72. Because 4 times 72 is equivalent to 288. And I've started my journey toward reducing this radical. Now, 4 is a perfect square. So because it's a perfect square, I can remove it by taking its square root. So I'm going to take it out front of the radical and leave it out front as 2, because the square root of 4 is 2. So I now have a question of 2 root 72. But I say to myself, is this as easy as it can possibly get? The answer is no, because 72 is still divisible by yet another perfect square. If I remember my trick for 9s, I think that 72 is going to be equal to 9 times 8. And 9 is a perfect square. So I'm going to change this to 9 times 8. And now, I think I can remove my 9. And when I do that, it will become a 3, because I'll take its square root. I have to remember when I remove something to multiply it by the number in front. So I'll have 2 times 3 times the square root of 8. Now, I am going to simplify this just a little bit. 2 times 3 is, of course, 6. And I say to myself, is this done? And I say, wait. It's not. And the reason why it's not is because 8 is still divisible by yet another perfect square. 8 is divisible by 4 again. So now I can write 8 as 4 times 2. So this would be 6 times the square root of 4 times 2. And I can once again remove that 4, just like I removed this 4 up here. And I'll get to, what's 4 square root 2? 2 times 6 is 12. So I'll have 12 root 2. Now, this is entirely reduced because I know there is no perfect square aside from 1 that divides into the number 2. As soon as I have a place where I can't remove any more perfect squares, that means that my radical is finished. Now, before we go ahead and hit stop, I'm going to remember that I should probably go back and double check on my work. Did I multiply by square roots as I removed them? And I did. But did I take the easiest path? And let's think about that for a second. Another pathway that I could have taken was the square root of, 288 is equivalent to 144 times 2. It's always best to take the largest possible perfect square out as fast as you can. So if you saw that the square root of 288 is the square root of 144 times 2, well, the square root of 144 is 12. So we're left with 12 root 2, and we get to that path much quicker. So just like you can drive to Toronto by going through Ottawa, you can get to a perfectly reduced answer by removing smaller squares, but it's probably best to remove bigger squares instead. And that's how you remove, or rather reduce, a radical.